Um, Hello everyone. So here we shall solve some more KCET questions on the KCET previous year questions on the chapter conic sections. So in the previous part we had solved till the question number 38. So in this part of conic sections we shall start from question number 39. Um, so if you have any questions regarding any of the steps of the solution or any other kinds of doubts if you have, then please write us in the comments section. We shall clarify them in the subsequent videos. um, and if you feel that you have more difficulty in any of the chapters, then also please mention the name of that chapter in the comments section. Then we shall give more priority on it and solve more and more questions on that chapter, which shall be helpful for your KCET exam. Also, the homeworks on every chapter will be uploaded in the Sapience Education application. Whose so please install our Sapience Education application, whose link has been provided in the description. So in question number 39, it is told the chord of the circle x square plus y square minus 4x equal to 0, which is bisected at 1, 0 is perpendicular to the line. So we know that, so this is the circle and here is suppose the chord. So now we know that the perpendicular which is drawn on the chord from the center of the circle, it means from the center of the circle, if a perpendicular is drawn on the chord, that line will bisect the chord. Okay. So it means that this point is 1, 0 and this is the center. So let this point be A. So CA is obviously perpendicular to this chord. So the chord which is bisected is perpendicular to the line. So we have to find the equation of this line which passes through the origin actually. No, which passes through the center of the circle. So therefore we know that the center of the circle x square plus y square plus 2gx plus 2fy plus c equal to 0. If this is the equation of the circle, then the center is given as, the coordinates of the center is minus g comma minus f. So therefore here we have g is equal to minus 2 and f is equal to 0. So therefore the center is at 2 comma 0. So therefore we have to find the line joining the points, 1 comma 0 and 2 comma 0 will be obviously perpendicular to this chord, will be perpendicular to the chord. So simply we need to find the equation of this line which joins the points 1 comma 0 and 2 comma 0. So therefore the required equation is that is, so it is y minus y1 that is equal to 0 minus 0 by 2 minus 1 to x minus x1. Okay, so this is 0, so y equal to 0 sector at the point okay. The chord of the circle bisected at this point So it means that y equal to 0, y equal to 0 is the x-axis. So this straight line is y equal to 0. So any straight line which is parallel to y equal to 0 will be also perpendicular to this chord. So it means that y equal to 1 also will be parallel to the x-axis. So y equal to 1 also will be perpendicular to this chord. So therefore option C is the correct answer. Then in question number 40 it is told the straight line 2x plus 3y minus k equal to 0 where k greater than 0 cuts the x and y axis at a and b. Okay, so it will cut the x-axis. So first we have to write it in the intercept form. So we can write it as 2x plus 3y equal to k. So then we can just say that x by k by 2 plus y by k by 3, that is equal to 1. So therefore this line will intersect the x-axis at the point k by 2 comma 0 and the y-axis at the point 0 comma k by 3. So this is the point A on the x-axis and this is the point B on the y-axis. So the area of the triangle OAB, where O is the origin, that is 12 square units. So it is told that the area of triangle OAB, that is 12 square units. The equation of the circle having AB as the diameter is. Then we have to find the equation of the circle which has AB as the diameter. So now, therefore the area of the triangle OAB will be equal to half base is k by 2 to height is k by 3, that is equal to 12. So therefore we can say that k square equal to 12 into 12. So k equal to 12. So k is equal to 12. So k should be greater than 0 also, it has been told. The equation of the circle having AB as the diameter is. So therefore if you take any arbitrary point on the circle x comma y, then the slope of PA into PB, that should be -1, since y angle in the semicircle is a right angle. So therefore the point B is 0 comma 4, 3 4s are 12, and point A is 6 comma 0. So therefore the equation of the circle with AB as the diameter is x y, which is slope is y minus 0 by x minus 6, y minus 0 by x minus 6 into y minus 4 by x minus 0, that is equal to -1. So therefore we can say this will be, y into y minus 4, that is equal to minus x into x minus 6. Therefore we can say that it will be y square minus 4y plus x square minus 6x, that is equal to 0. So or we can say that x square plus y square minus 6x minus 4y, that is equal to 0. So option B is the correct answer. So here this will be option B is the correct answer. Okay. Then in question number 41, let P x comma y be the midpoint of the line joining the point 1 comma 0 to a point on the curve this uh, then the locus of P is symmetrical about. Okay. So P x comma y is the midpoint of the line joining this to a point on this curve to a, to a point C, suppose, on this curve. So and P is the midpoint x comma y of A and C, and the equation of the curve C is y square equal to x minus 1, x plus 1 into x plus 5 minus x plus 3 into x plus 2. So that will be y square equal to x square plus 6y plus 5 minus x square plus 5y plus 6. So this will be y square will be equal to x square will cancel, 6y minus 5y, that is y, 5 minus 6, that is minus 1. Sorry, this is x. This will be x. So this is x minus 1. Y square equal to x minus 1. So it means that if I take, okay, so x will be equal to y square plus 1. So the point C can be written as y square plus 1 comma y. Then its midpoint is suppose h comma k. So at the end we can replace h and k with x and y. So then h will be equal to y square plus 2 by 2 and k is equal to y by 2. So therefore we can say that 2h, that is equal to y square plus 2. It means that 2h equal to y is equal to 2k. So 2k I can place here. So this will be 2k whole square plus 2. So this will be 2h, that is equal to 4k square plus 2. It means that 2k square plus 1, that is equal to h. Means that 2y square plus 1 equal to x, or we can say y square equal to x minus 1 by 2. So this is the equation of locus of the point P. This is the locus of the point P. Now therefore this we can write it as y square equal to half into x minus 1. So if we write, so this is the parabola y square equal to 4ax, but here y square equal to 4a into x minus some constant c, suppose. So it means that at x equal to c comma 0 will be the point where the axis will intersect the parabola. So the axis of the parabola will intersect the parabola at the point c comma 0. So here it means that this uh, the locus of P, which is the parabola, it is symmetrical about the x-axis. So this curve, it is symmetrical about the x-axis. (42). So in question number 42 it is, so here, okay, symmetrical about x-axis, so option A is the correct answer. Then it is told that two circles centered at 2, 3 and 5, 6 intersect each other. If the radii are equal, the equation of the common chord is, radii are equal. So there are two circles. So the equation of one circle is x minus 2 whole square plus y minus 3 whole square that is equal to r square, and the other circle is x minus 5 whole square plus y minus 6 whole square that is equal to r square. Since their radii are equal and their centers are at 2, 3 and 5, 6. Now the equation of the common chord is given as, the equation the common chord is given as equation of common chord is given as s1 equal to s2. So therefore if we equate them, so then we will have x minus 2 whole square plus y minus 3 whole square minus r square that is equal to x minus 5 whole square plus y minus 6 whole square minus r square. So minus r square and minus r square will cancel. Then we will have x minus 2 whole square minus x minus 3 whole square that is equal to y minus 6 whole square minus y minus 3 whole square. So this will be a square minus b square, so a plus b into a minus b. So this is 2x minus 5 into a minus b, so it is x minus 2 minus x plus 3. So this will be equal to a square minus b square. So this is a plus b to a minus b. So y and y will cancel. So this will be 2x minus 5 into 2x plus 1. X and x will cancel out to 1. That is equal to 2y minus 9 into minus 3. 2x minus 5 that is equal to minus 6y plus 27. 6y plus 2x that is equal to 32. So therefore be x plus 3y that is equal to 16. There is something wrong here, so a plus b into a minus b, a plus b into a minus b minus 3 . So this will be sorry, this is 5. This is 5 actually, it is not 3. This is 5. This is 2x minus 7. So this is wrong. So this part will be x minus 2 whole square minus x minus 5 whole square. That will be x minus 2 plus x minus 5 into x minus 2 minus of x plus 5. That will be equal to y minus 6 plus y minus 3 into y minus 6 minus of y plus 3. So these two will cancel. Here these two will cancel. So this will be equal to 2x minus 7 into 3 into 2y minus 9 into minus 3. 3 and 3, that will cancel. This will be 2x minus 7, that is equal to minus 2y plus 9. So then this will be 2x plus 2y, that is equal to 9 plus 7, that is 16. So this will be x plus y, that is equal to 8. So, or we can say that x plus y minus 8, that is equal to 0. So option D is the correct answer. Then it is told that the equation of the circle centered at 4, 3 and touching the circle externally is. Okay, so now here we have the circle which is having radius 1 unit and its equation is x square plus y square equal to 1 and its center is the origin, and there is another circle whose center is at 4, 3 and it will touch this circle externally. So we have to find the equation of this circle. So now therefore the distance in between their centers should be equal to the sum of their radii, since they are touching each other externally. So we'll tell that since the two circles touch each other externally, since the two circles touch each other externally, since the two circles touch each other externally, so the distance between their centers equal to sum of their radii. So the distance between their centers is equal to the sum of their radii. So therefore I can, its radius is 1, so therefore I can say r plus 1, that will be equal to the distance between their centers, which is 5. So r is equal to 4. So therefore its radius is 4 units and its center is 4, 3. Therefore the equation of the circle is x minus 4 whole square plus y minus 3 whole square, that is equal to 4 square. So therefore we can say that it is x square minus 4x plus 16 plus y square minus 6y. No, this will be y square plus minus 8x, sorry, plus 16 plus y square minus 6y plus 9, that is equal to 16. So 16 and 16 will cancel. So this will be x square plus y square minus 8x minus 6y plus 9, that is equal to 0. Minus 8x minus 6y plus 9. So option B is the correct answer. Then it is told that in question number 44 it is told the points 1, 0, 0, 1, 0, 0, 2, 2k and 3k where k not equal to 0 are concyclic. So if they are concyclic, they all should lie on the same circle. So this is the circle. Now this is the point 0, 0. This is the 1, 0 is here. 0, 1 is also here. So it means that should be like this. This is the x-axis, this is the y-axis. The circle should be somewhat like this. It should pass to the origin, and it should pass to the points 0, 1 and 1, 0 also. Now it means that now this is a right angle. It means we know that angle in a semicircle is a right angle. So therefore the 2 points joining the line joining these 2 points should be the diameter of the circle. This line segment should be the diameter of the circle. Therefore we can find the equation of the circle, and 2k, k also, 2k, 3k also lies on the circle. So now first we can find the equation of the circle. So if we take any point x, y, then obviously this will be a right angle. So means PA, means the slope of PA and PB, their product should be -1. Since PA is perpendicular to PB, so therefore the slope of PA into the slope of PB should be -1. So by using this concept we can write the equation of the circle. So this will be y minus 0 by x minus 1 into y minus 1 by x minus 0, that is equal to -1. So therefore we can say that y into y minus 1 plus that is equal to minus x into x minus 1. So therefore we will have y square minus y, that is equal to minus x square plus x. So therefore we can say that this will be x square plus y square minus x minus y, that is equal to 0. Now 2k, 3k also lies on the circle, so it should satisfy the equation of the circle also. So therefore we can say that 2k whole square plus 3k whole square minus 2k minus 3k, that should be equal to 0. Therefore we can say that 4k square plus 9k square minus 5k, that is equal to 0. So 9 plus 4, that is equal to 13k square. 13k square minus 5k, that is equal to 0. So k into 13k minus 5, that is equal to 0. So therefore k is equal to 0 or k is equal to 5 by 13. So if k is 0, then it will come with this point only, which is the origin. So here it is told that k should not be 0, so k should be 5 by 13. So option C is the correct answer. Now here it is told that the locus of the point of intersection of the tangents drawn at the ends of a focal chord of the parabola. The locus of the point of intersection of the tangents drawn at the endpoints of the focal chord of a parabola. Okay. So this is a parabola whose equation is x square. No, sorry. This is a parabola, but x square equal to minus 8y means the parabola is downwards. It is concave downwards. So the equation of this is x square equal to minus 8y. Now locus of the point of intersection of the tangents drawn at the ends of the focal chord. So let's say this is the focus F, so this will be a focal chord, and the locus of the point of intersection of the tangents drawn at the endpoints. Now this is also a tangent drawn at the endpoints. Okay. So point of intersection, that is P x comma y, suppose h comma k. You have to find the equation of locus of the point of intersection of these tangents which are drawn at the endpoints of the focal chord. Let's say the endpoints are A and B. So we know the rule, that is the tangents drawn at the endpoints, the tangents drawn at the endpoints of a focal chord, the tangents drawn at the endpoints of a focal chord of a parabola, the tangents drawn at the endpoints of a focal chord of a parabola intersect at right angles on the directrix. Intersect at right angles on the directrix. Intersect at right angles on the directrix. So therefore the locus of the point of intersection, locus of the point of intersection the locus of the point of intersection of the tangents drawn at the endpoints of the focal chord, it's the equation of the directrix itself. So the locus of the point or points of intersection of the tangents drawn at the endpoints of a focal chord is the equation of the directrix itself. Is the equation of the directrix of the is the equation of the directrix of the parabola. Directrix. Okay. So here the equation of the directrix. So here x square equal to 4ay. So if the equation of the parabola is x square equal to minus 4ay, then the equation of the directrix is given as equation of the directrix is given as y equal to a. Y equal to a. So here 4a equal to 8. Here we have, so therefore here we have 4a is equal to 8, so a is equal to 2. So therefore the equation of its directrix is y equal to 2. So the required equation of the locus of the point of intersection of tangents at the endpoints of the focal chord is y equal to 2 only. So option D is the correct answer. Then in question number 46 it is told the condition for the line y equal to mx plus c to be a normal to the parabola y square equal to 4ax is. So this line is a normal to this parabola. Normal, it means that it is perpendicular to the tangent. So now therefore the equation of the tangent to the parabola, equation of tangent to the parabola y square equal to 4ax at the point x1 comma y1 is given as y1 that is equal to 4a into x plus x1 by 2. So that will be y1 that is equal to 2ax plus 2a into x plus x1 actually. Okay, so therefore here the slope of the tangent that is given as 2a by y1. So the slope of the normal at this point, therefore the slope of the normal at the point x1 comma y1 to the parabola y square equal to 4ax is minus y1 by 2a, minus y1 by 2a. Since the normal is perpendicular to the tangent, so it means that the product of their slope should be minus 1. So therefore we can say, therefore the equation of the normal to the parabola y square equal to 4ax at the point x1 comma y1 is given as y minus y1 that is equal to m, which is minus y1 by 2a into x minus x1. Therefore we can say that it will be y equal to minus y1 by 2a into x plus y1 plus x1 y1 by 2a. Okay. So therefore we can say, therefore this will be the slope and this will be the value of c. So therefore we can say that minus y1 by 2a that should be equal to m, and c should be equal to y1 plus y1 into 1 plus x1 by 2a. Okay, so therefore y1 should be equal to minus 2m, and we know that the point lies on the parabola also, so it means y1 square is equal to 4a into x1. Therefore x1 is equal to y1 square by 4a. So therefore x1 is minus 2am whole square by 4a. Minus 2m whole square by 4a. So this will be 4a square m square by 4a. So this will be am square. So therefore C will be equal to minus 2am into 1 plus am square by 2a. So this will be implies C will be equal to minus 2am plus or minus 2am into am square by 2a. So 2 will cancel, a and a will cancel. So C will be equal to minus 2am then minus am cube. So C equal to minus 2am minus am cube. So it means that option B is the correct answer. Then in question number 47 it is told the eccentric angle of the point 2 comma root 3 lying on the eccentric angle of the point lying on x square by 16 plus y square by 4 equal to 1 is the eccentric angle of the point. Okay. 47. So eccentric angle means that if the equation of the ellipse is x square by a square plus y square by b square equal to 1, then any point on the ellipse x comma y, can be represented as a cos theta comma a cos theta comma b sin theta, where theta is called the eccentric angle, Theta is called the eccentric angle. Okay, so now therefore the eccentric angle of the point 2 comma root 3 is, so therefore here in this ellipse it is x square by 16 plus y square by 4 equal to 1. So here a square is 16 and b square is 4, so therefore a is equal to 4 and b is equal to 2. So therefore the point 2 comma 3, 2 is equal to a cos theta and b, which is 2, is equal to root 3 sin theta. So therefore cos theta will be equal to half, root 3, here this is something wrong. So b is 2, so therefore it is 2 sin theta. So any point on the ellipse can be represented as 4 cos theta comma 2 sin theta. So that is equal to 2 comma root 3. So 4 cos theta is 2 and root 3 is equal to 2 sin theta. So cos theta equal to 2 and sin theta equal to root 3 by 2. So therefore theta should be equal to pi by 3. Means cos pi by 3 is half and sin pi by 3 is root 3 by 2. So option D is the correct answer. Then in question number 48 it is told, so it is asked to find the distance of the focus of x square minus y square equal to 4 from the directrix which is nearer to it. So this is a hyperbola. And this is the x-axis, this is y-axis, and here we have one focus f1 and this one is f2. Now the distance of the focus from the directrix which is nearer to it, this one. So the equation of the directrix here, it is x equal to a by e, is that it will intersect the x-axis at the point a by e comma 0, and the focus is at a e comma 0, where e is the eccentricity of the hyperbola. So here the eccentricity of the hyperbola is square root of 1 plus b square by a square, and here it is x square by 4 minus y square by 4 equal to 1. So it means here a is all a square and b square both are equal to 4. So it is a rectangular hyperbola. It is 1 plus 1, that is equal to root 2. So its eccentricity is root 2. Therefore the the required distance of the focus from the directrix, is given as ae minus a by e. So that will be equal to, if I take e as the LCM, this will be ae square minus a. So this is a into e square minus 1 by e. A into e square minus 1 by e. Now here a is how much? So a is equal to b, that is equal to 2. So therefore that will be 2 into root 2 whole square, that is 2 minus 1 by root 2. So that is 2 by root 2, that is equal to root 2. Root 2 units. So option C is the correct answer. Then here it is told the locus of a point which moves such that its distance from the x-axis is twice its distance from the line x minus y equal to 0 is. The locus of a point which moves in such a way that its distance from the x-axis, it means its distance from y equal to 0, which is nothing but its x coordinate. Magnitude of the x coordinate is the magnitude of the y coordinate is its distance from the x-axis. And that is twice its distance from the line x minus y equal to 0. So let's say this is the line x minus y equal to 0. So therefore this d you have to find. So therefore the distance of the point P x comma y from the line x minus y equal to 0 is given as, so that will be given as d, that is equal to mod of x minus y by square root of 1 square plus 1 square. So that will be, so d will be equal to mod of x minus y by root 2. Okay. So therefore that will be mod of y square, that will be equal to mod of x minus y whole square by root 2 whole square. So that will be y square will be equal to x minus y whole square by 2. This will be 2y square, that is equal to x square plus y square minus 2xy. So now it is told that its distance from the x-axis, it's twice its distance from this line. It means it is 2 times d, 2 times of this. Okay, so that is, sorry, there is something wrong here. So this will be 2d whole square. Okay, so this will be y square equal to 2d, that is root 2 into mod x minus y, its whole square. So this will be y square equal to 2 into x minus y whole square. So then this will be y square equal to 2 into x square plus y square minus 2xy. So this will be y square equal to 2x square plus 2y square minus 4xy. So if we simplify it, then we will have, this is obviously 2x square plus 2y square minus 4xy, that is equal to y square. So therefore this will be 2x square plus y square minus 4xy, that is equal to 0. So option B is the correct answer. Okay. So then in question number 50 it is told, if 2x square plus 2y square minus plus 4x plus 5y plus 1, that is equal to 0, and 3x square plus 3y square plus 6x minus 7y plus 3k, that is equal to 0. So these two circles are orthogonal, then find the value of k. So these two circles are orthogonal, means that x square plus y square plus 2x minus 7 by 3y plus k, that is equal to 0. And from here we have x square plus y square plus 2x plus 5 by 2y plus 1 by 2, that is equal to 0. Is equal to 0. Then the value of k is, okay, so these two circles are orthogonal. So we know that if two circles are orthogonal, then 2 into g1 g2 plus f1 f2, that is equal to c1 plus c2. So here g1 is 1, since it is 2gx, and f1 is 2fy, so it is minus 7 by 6. And here also g2 will be 1, and g1 f2 is 5 by 4. So therefore, and c, here c is equal to k, and here c is equal, c1 equal to k and c2 equal to half. So therefore we should have 2 into g1 g2, 1 into 1 plus f1 f2. So it is minus 7 by 6 into 5 by 4. So that should be equal to c1 k plus half. So from here we have to find the value of k. So therefore we have 2 into 1 minus 7 5 is 35, 35 by 6 4 is 24. So that is equal to k plus half. So therefore we can say that k equal to 2 into this 24 minus 35 by 24 minus half. So k will be equal to so 2 12s are 24, and this will be minus 11 by 12 minus half. So k will be equal to, the LCM is 12. This will be minus 11 minus 2 6 are 12. So this will be, k will be equal to minus 17 by 12. So option D is the correct answer. And then in question number 51 it is told that the number of common tangents of x square plus y square minus 6x minus 8y plus 9 equal to 0 and x square plus y square equal to 1 is. So now this circle is having the center is at minus g comma minus f, so that is 3 comma 4, 3 comma 4. So here obviously g is minus 3 and f is minus 4, so minus g comma minus f is 3 comma 4, and here the radius is square root of g square plus f square minus c, so that will be square root of 3 square plus 4 square minus 9. So this is 9 and 9 will cancel, so square root of 4 square is 4, so the radius is 4, and here the center is at 0 comma 0 and the radius is 1. So it means that this circle is at center 0 comma 0 and the radius is 1, and here the radius is 3 comma 4. Radius is the center is 3 comma 4 and the radius is 4 units. So now here first we have to find the distance in between their centers. So therefore the distance between their centers that is equal to square root of 3 square plus 4 square, that is equal to 5 units, and the sum of their radii is also same, which is also equal to 4 plus 1. So therefore the distance in between their centers equal to the sum of their radii. So they will just touch each other externally. So there will be 3 common tangents, 1, 2 and 3. So there are 3 common tangents. So therefore option C is the correct answer. Okay. Then here it is told the center of a circle which cuts x square plus y square plus 6x minus 1 equal to 0 and x square plus y square minus 3y plus 2 equal to 0 and x square plus y square plus x plus y minus 3 equal to 0 orthogonally. So we have to find the center of a circle which cuts all these 3 circles orthogonally. So let the equation of that circle which cuts all these 3 circles orthogonally, equation of that circle be x square plus y square plus 2gx plus 2fy plus c, that is equal to 0. So now therefore since it is cutting them orthogonally, so therefore we can say that here actually g1 that is equal to 3 and f1 that is 0 and c is equal to minus 1, c1, and here also g2 that is equal to 0 and f2 that is equal to minus 3 by 2 and c2 that is 2, and here g3 that is half and f2 that is f3 that is equal to also half and c3 that is minus 3. So therefore 2 into g1 g2, so g into g1 that is 3 plus f into f1 that is 0, that should be equal to c1 plus c2 that is minus 1. So here we get one of the equations, that is 6g that is equal to c minus 1. This is one of the equations, and another equation will be 2 into g into 0 plus f into minus 3 by 2 that is equal to c plus 2. So therefore you can say that 2 and 2 will cancel, so this will be minus 3f that is equal to c plus 2. So this is equation 2, and then you can say that 2 into g into half plus f into half that is equal to c minus 3. So g plus f that is equal to c minus 3, which will be equal to 3. which will be the third equation. So from here we can also say this is minus 6f, that is equal to 2c plus 4. Okay. So now if we add these two equations, the first and the second equation, then we will get that is 6 into g minus f. 6g minus f, that is will be equal to c minus 1 c minus 1 plus 2c minus 4. Sorry, 2c plus 4. So it means I will have that 6 into g minus f, that is equal to 3c plus 3. So therefore we can say g minus f, that is equal to c by 2 minus c by 2 plus 1 by 2. And we have g plus f. G plus f is equal to c minus 3. C minus 3. So if we add them, then we will get that 2g. 2g, that is equal to c minus 3 plus c by 2 plus half. So therefore 2g, that is equal to 3c by 2. Then 2 3 is 6, so minus 5 by 2. Sorry, this is 2g. And 6g, that is c minus 1. So therefore you can say 6g, that is equal to 3 into this. So 3 3 is a 9, 3 5 is a 15. And that is also equal to c minus 1. So therefore we can say that 9c by 2 minus c, that is equal to 15 by 2 minus 1. So therefore 7c by 2, that is equal to 13 by 2. For c is equal to 13 by 7. C is equal to 13 by 7. And from here we can find g. So g will be equal to 3c by 4 minus 5 by 4. So that is equal to 3 by 4 into 13 by 7 minus 5 by 4. So this will be equal to 4 7s are 28, and this is 13 3 are 39 minus 7 5 are 35. So this is 2 by 28, that is equal to 1 by 14. So g is equal to 1 by 14, but it is not. Okay, sorry, this is 39 minus 35, that is 4 7s are 28, so that is 1 by 7. Sorry, this is 1 by 7. And f will be equal to f is equal to c plus 2 by minus 3. Or we can say that c minus 3 minus g. C minus 3 minus g. So that will be c is equal to 13 by 7 minus 1 by 7 minus 3. So that is 12 by 7, and 7 3s are 21. So this is minus 9 by 7. So therefore the center is given as obviously minus g comma minus f. So that will be minus g is minus 1 by 7 comma minus, that is plus 9 by 7. Minus 1 by 7 comma minus 1 by 7 comma plus 9 by 7. So option D is the correct answer. Okay. Then it is told the length of the latus rectum of this parabola. So this is 3x square plus 6x minus 4y minus 3, that is equal to 0. So therefore we can say this is x square into x square plus 2x plus 1, but it is not there. Plus 3 is not there, so I can subtract 3. So minus 3 minus 4y minus 3, that is equal to 0. So this will be 3 into x plus 1 whole square, that is equal to 4 y plus 6. So this will be 3 into x plus 1 whole square, that is equal to 4 into y plus 3 by 2. So this we can write x plus 1 whole square, that is equal to 4 by 3 into y plus 3 by 2. So if I take this as some capital X, this is capital Y, then this, the equation of this parabola is of the form x square equal to 4 by 3y. So we know that x square equal to 4ay if I have, then the length of the lattice rectum, length of the LR, that is given as 4a units. So here 4a is 4 by 3. So the answer is 4 by 3 units is the length of the lattice rectum. So option B is the correct answer. Then question number 54 is told the sum of the reciprocals of the focal distances of a focal chord. Sum of the reciprocals of the focal distances of a focal chord PQ of y square equal to 4ax. So if we have y square equal to 4ax, then the equation, then the sum of the reciprocals of focal distances focal chord PQ. So it means the distance of any point from the focus is called the focal distance. The focal distance of any point from the focus is called the focal distance, so PF. So that is also equal to the distance from the directrix. The distance from the directrix, whose equation is x equal to minus a. So this point is x comma y. So this length PM. So PF equal to PM. So PM will be mod of x plus a. Mod of x plus a. This length is x units. This length is a units. So mod of x plus a units. So the sum of the reciprocals of focal distances of a focal chord. So suppose the focal chord will cut the parabola at the points x1 comma y1 and x2 comma y2. So then sum of the reciprocals of the focal distances. Therefore sum of the reciprocals of the focal distances, that will be equal to 1 by x1 plus a plus 1 by x2 plus a. So that will be how much? So that will be equal to x1 x2. You can say x1 means it will be x1 plus a into x1 minus x2 plus a. x1 plus a into x2 plus a. And this will be x2 plus a plus x1 plus a. So it will be x1 plus x2 plus 2a divided by x1 x2 plus a into x1 plus x2 plus a square. So this will be, so now here, from here we can say that now we can take the points as x1 is equal to 80 square and y1 is 280. Then x2 will be, so we know that t1 t2 equal to minus 1, so t2 will be equal to minus 1 by t. Okay, so this will be a by t square and y2 will be minus 2a by t. So therefore the required sum of the reciprocals, so let us call the sum of the reciprocals of focal distances as s, suppose. So this is s. So therefore s will be equal to s x1 plus x2, that is at square plus a by t square, plus this will be 2a, and that divided by x1 x2, that is a square, x1 x2 is a square, plus x1 plus a into x1 plus x2 plus a into x1 plus x2 is at square plus a by t square, at square plus a by t square is at square plus a by t square, then plus a square. Plus a by t square. Okay, so this will be equal to, this will be a into t square plus 1 by t square plus 2a divided by, this will be a square into, this is 1, so this is, sorry, this will be 2 plus t square plus 1 by t square. Okay, so here also if I take a as common, this will be t square plus 1 by t square plus 2, and this is also a square into 2 plus t square plus 1 by t square, so these two will get cancelled, so this will be 1 by a, so the sum of the reciprocals is equal to 1 by a. So option A is the correct answer. Then here it is told, if the foci of x square by 16 plus y square by 4, that is equal to 1, and x square by a square minus y square by 3, that is equal to 1, coincide. So the foci of this are plus minus ae comma 0. So ae we know that is equal to square root of 1 plus b square by a, 1 minus b square by a square into a, sorry, so this will be square root of a square minus b square. So here a square is 16 and b square is 4, so this will be 16 minus 4, so that is root over 12, so that is plus minus root 12, or you can say 2 root 3 comma 0. And here also the foci are plus minus ae comma 0, but here ae will be that is a into e is square root of 1 plus b square by a square, so that will be root over a square plus 3, so this will be plus minus root over a square plus 3 comma 0. So the foci of these two coincide actually, so therefore we should tell that root over a square plus 3, that should be equal to 2 root 3, so therefore a square plus 3, that should be equal to 12 if we square both sides. Then we will have a square equal to 9, so a is equal to plus of, so a is equal to 3, since a cannot be negative, a is the length of the transverse axis, so it cannot be negative, so a should be equal to 3, so option D is the correct answer. Okay, so so here we shall end the fourth part of this conic section. So the remaining questions we shall solve in the next part of conic sections. Okay, so hope you have understood the solutions of each of these questions which we have solved in this part 3 or in this part 4 of conic sections, and so the remaining questions we shall solve in the next part, which is in part 5. So also please install our Sapience education application, where we shall upload our some important KCET previous year questions on every chapter, which shall be helpful for your KCET exam. So Thank you everyone. Bye.